Hello, welcome to the NMR spectroscopy lecture number 5. In this lecture, we will study how to interpret NMR spectrum. We will focus on proton NMR spectrum. Proton NMR. So, in order to interpret the proton NMR spectrum, you need to know about the splitting. What are the proton NMR shift values? So we will not study about much of the theory about the NMR. We will go straight to the practical part. So in order to know the proton NMR shift values, you need to always keep this table with you because you can't remember all these values. So whenever you receive NMR spectrum, you need to look at this chart and see where your proton is. So if your proton is attached to the carboxylic group, so its value will lie between 10 to 12. If it is attached to the, for example, amino group NH2 or NH amide, so its proton value will be around 0.5 to 5. So these are just and you can say that these are just a range of different values. For example, CH3, the proton in CH3 can be appear at 2 or 3 or 4. It depends on other factors. For example, your CH3 group attached to a electronegative atom or not, or it is attached to the aliphatic carbon, like this CH3 group is attached to the aliphatic part, or this CH3 group is attached to the aromatic ring. For example, if it is attached to the aromatic ring, then this will be the range of the values. So for example, if the proton is attached to the aromatic ring, like I'm gonna show this one. This proton is attached to the aromatic ring. If this is attached to the aromatic ring, then its value will be around 7. So if you find in the spectrum your value is around 7, so you are sure that this may be an aromatic ring, but maybe not, because there might be alcoholic group, maybe 7 value may become here if this is H group attached to the C double bond C. So there are many different aspects we will study in the next lecture. So this is just a basic lecture. In this lecture we will next look at an example how to see the splitting and how to interpret the spectrum. Like this is a spectrum of this molecule. First of all, the first step you have to do is to open the molecule structure. Like this is C H H so I am going to open the whole structure. So this is the structure of that molecule. Whenever you have to study a spectrum, you need to open the structure, and after that you have to number the carbon. You can number the carbon like from left to right or right to left. It depends upon you what you wish. So if you want that I have to number like in that way, most suitable, straight 1 2 3 4. So the proton which are attached to the same carbon are in the same environment. Like the proton attached to the carbon 1 We may name them as A type of protons. So they are in the same environment, mean they are same type of protons. If they are same time, so there should be only one signal in the spectrum. There should not be three signals, because all the protons are same. So there should not be the three signals in the spectrum. There should be only one signal in the spectrum. For the Ha type of proton, you may name them as H111 or anything else. So there is a no proton here, no proton here. On the third carbon, there is a two protons. So these are B type. They are attached to the same carbon, so they are in the same environment. So they are B type of protons. You may name them by any other letter, but this is most easy for me. So I name them as C type of protons, A, B, C. So these three protons are same, so there is just there will be a one signal in the spectrum. These B type of protons are the same, so there would be one signal in the spectrum. So how many type of protons are in this molecule? There are three type of proton. Three type of protons. Three type of protons mean three signals. So this is 1, 2, 3. So there are only three signals are appearing in the spectrum. So next is the splitting. We will look at the splitting. So one signal is splitting into a triplet form. This is quad form. Like if there are three peaks, 1 2 1, 1 2 2 1, like four peaks. This is a quartet. This is a quartet. Quartet represent 4, triplet represent 3. So one more thing, for example, in the splitting you have to do n plus 1. So this is a splitting in the NMR spectrum. For example, let's look at the signal of the Hc proton. So Hc proton will give only one signal. So if I want to look at the splitting of this signal, Hc proton signal, so it will give us a triplet. So why it would give us a triplet? Because there are two protons. There are two protons in the neighborhood. So there are two protons. So n is equal to 2. 2 plus 1, 3. So it will give us a triplet signal. So in the whole spectrum, where is a triplet? This one. So this one is the signal of the Hc protons. Okay. So next, this is Hb protons. Hb protons. So there will be only one signal because these are in the same environment, but the splitting of the signal would be different. There are three protons in the neighborhood. 1 2 3. So these three protons mean n is equal to 3, and 3 plus 1 4, quartet. So where is the quartet? So Hb type of protons will give us a quartet. So next, see Ha type of proton. So Ha type of proton would be give only one signal because these are in the same environment. Let's see the splitting of Ha type of protons. So there is no proton in the neighborhood because this carbon is not bearing any proton. This has oxygen, so there will be no splitting for the Ha proton. So when there is a no splitting, then there would be a singlet. So this is singlet, so it will represent Ha type of protons. So in order to look at the different values, why this value is 1.26, so this is a just computational result. So CH3, this CH3 protons will go to the 1.26, this will be 4.12, and this will be 2.04. So whenever you receive a spectrum, you have to look at the, for example, if the molecule is missing, the molecule is not given to you, you have to interpret that what is my molecule. You have received just a blank spectrum. For example, you are doing an experiment in the lab and you form a product, or you receive any product from lab. So you have to check that this is my molecule or not. So you will check the peak. So where my peak will, for example, if there is a peak 4, at the 4 you will look at the NMR, proton NMR spectrum table, that what would be the possibilities. For example, CH2CH group proton maybe appear around 4, like this ketone, the CH group attached to the ketone will appear in this range. So the purpose to tell you about that is, for example, there may be different scenario. For example, when the compound is missing, when the spectrum is given, compound is given. So when the spectrum is given, compound is given, then it is very easy for you to interpret the spectrum, because from the proton you can see the splitting, and if the splitting is, for example, this is quartet, so this is only for HB type of proton, this is not for the HC type of proton. So you quickly got the idea that this is for the HB type of proton. So this is for the today. In the next lecture we will study the carbon NMR. Thank you so much for watching the video. If you like the video, please subscribe the channel. Thank you.